Hi, I'm Darius Pupeikis. I'm professor at Kaunas University of Technology, Faculty of Civil Engineering and Architecture. I'm a head of Center for Smart Cities and Infrastructure. Digital twin for Kaunas University of Technology campus buildings, operational carbon and indoor climate monitoring and improvement. The construction and built environment is responsible for almost 40% of carbon dioxide emissions globally. The project Digital Twin for KTU buildings operational carbon and indoor climate monitoring and improvement presents the CO2 footprint of KTU campus buildings broken down by different types of energy and the aggregation of buildings, systems and equipment. We utilize various digitalization technologies in order to create digital twin. We use photogrammetry, building information models, 360 panoramas. We have a lot of implementation of IoT infrastructure and different kind of sensors, building management systems, data. All this data comes together in order to reflect specific use case. In our case, it's a CO2 carbon footprint monitoring. The monitoring is provided from various APIs by collecting data from different sensors into a single platform called middleware. The operational CO2 footprint consists of the common types of energy and their positive or negative impact on the CO2 equivalent. EV charging and solar power generation gives a positive effect, so the results are negative. The most significant impact comes from electricity and thermal energy consumption during the heating season. Federated hourly data provides more granularity and provides aggregated CO2 footprint data every hour. Detailed results allow the causes of high emissions to be investigated and decisions to be taken. Buildings operational carbon monitoring and improvement cycle. Data collected using various IoT data transmission protocols, taking advantage of each. More than 2,000 parameters streamed in real time via Zabbix middleware. We have quite a lot of installations of different types of sensors. This sensor is responsible for broadcasting data about indoor temperature, relative humidity, VOC, so-called volatile organic compound. Accurate and reliable information on utilities is essential for efficient energy management and control of the CO2 footprint. Consumption of electricity from the grid generates a significant CO2 footprint, but is seen to positively offset the impact of solar energy on sunny days. Huge impact of thermal energy consumption on heating and hot water for 22 buildings in the campus. On average, as much as 250 kilograms CO2 equivalent per each hour in March. Real-time information on EV charging station, availability and other parameters enables convenient charging and use of green energy. KTU infrastructure personnel finds it very useful to compare EV charging stations utilization in terms of energy consumption and energy price in Nord Pool stock. The average utilization of EV chargings in terms of days and hours of the week provides opportunities to encourage more efficient utilization. Real-time measurement of the generation of 4 types of waste and their CO2 footprint from student dormitory. The most significant impact is on the generation of general type of waste from Tuesday to Thursday. By demonstrating the CO2 footprint, we create awareness for people to generate less waste. Detailed monitoring of the operational CO2 footprint is carried out in the most of KTU's state-of-the-art buildings, the prototyping laboratory mLab. The building is enriched with sensors that measure different types of energy: electricity, thermal energy, waste generation, ventilation, water consumption, and wastewater disposal, solar energy. Occupancy data is very important in terms of energy consumption and operational carbon. 360 panorama tours technology is very useful to identify indoor. As the building has installed renewable energy sources, I mean heat pump plus solar power plant, the impact of thermal energy is not significant during this period. In general, mLab building demonstrates a relatively low level of CO2 emissions compared to other campus buildings. And here we have main heat generation devices, heat pumps, and centralized heating networks, all the pipings, and as well various sensors like smart meters, which provides us data about kilowatt hours of thermal energy consumption. Here we have main water inlet pipe with water meter enriched with sensors to measure our water consumption. Deeper understanding of the causes of the operational CO2 footprint requires detailed view in terms of object, equipment, systems, floors, rooms, etc. Bimodal data, I mean separated geometry classes properties linked with 360 panorama tour photos, tags, photogrammetry, and real-time sensor data provides crucial detailing capabilities. The integration of reality capturing, bimodals, 360 panorama tours, and IoT technologies enables to leverage strengths of each technology. Effective energy management with real-time monitoring is essential to reduce CO2 emissions more effectively. Ensuring indoor microclimate parameters, such as temperature and relative humidity, are essential components that determine energy consumption and CO2 emissions. We get a lot of data from here about the inflows, outflows, about the energy consumption. Appropriate data analytics and artificial intelligence predictions are crucial for making correct and timely decisions on energy management. We believe that our project has really great potential to grow because we need we need to measure, count, evaluate our operational carbon footprint, and we believe that the main part goes to energy consumption. That's why our digitalization technologies could help monitor and improve our built environment in terms of operational carbon mitigation and reduction of energy consumption.